So we're continuing our discussion about transformations. We're reviewing quickly our reflections and our translations. How would we shift an absolute value of x graph if we want it to go left 2 and up 5? What would it look like? We've got the absolute value of x, right? What are we going to do to make it to go left 2? Where does the plus 2 go? Inside your function, okay? Inside the absolute value in this case. And then if we want it to move up 5? Good. All right. Second question. So reflecting over the x-axis, which coordinate has to change? The y changes, right? If we're flipping over the x-axis, our y coordinate has to change, which means if f of x is y, we want that whole function to change, okay? So our new g of x looks like what? Does the negative go outside the squaring function or inside? It goes outside. Outside your x squared is going to change the whole thing, right? If we wanted to just change x, we'd have to put it inside parentheses being squared. Okay? All right, so our next topic, our next type of transformation deals with vertical stretches and compressions. When we do a vertical stretch, your x values do not change. Okay, x is our horizontal movements. If we're doing a vertical stretch, we're changing our y values. Okay, and we simply multiply them by something bigger than 1 that will cause them to stretch. All right, so if I take my whole function and multiply it by 2, I'm making it twice as tall. Okay, so what you're going to see is some number in front of your function. As long as that a value is bigger than 1, it's going to stretch your graph. Okay, so we have some pictures here. Our initial function was the blue one. The red one we have stretched. We've made it get taller. Okay, the green one we've done a vertical compression on. So we've taken all our y values and we've tried to scrunch them down, compress them. That happens when your a value is between 0 and 1. Okay, so bigger than 1, it's going to stretch it. Something between 0 and 1, like a half, 2/3, it's going to scrunch it down. Okay, it's going to make your y values get shorter. In both cases, the x values do not change. All right. So our first example says we have a table that represents the function f of x. What are the corresponding values for g of x and possible graphs for both of them if g of x is 3 times f of x? That means our a value is 3. We are multiplying all of our y values by 3. Okay? So let's start out by graphing our initial function. So just take a few minutes and plot those points. Sorry, 5, -2. Okay, so that's my original function. Yes? Label that f of x. Now, g of x, it says, is supposed to be 3 times as tall. So we are going to take all of our y coordinates and multiply them by 3. So instead of a 2 here, we're going to have a 6. Instead of a -3, we're going to have -9. We're just making all of these 3 times as big. Okay? So we're using the same x values, but now we're going to pair them up with our g of x values. Okay, so plot those points. So at -5, we are now up at 6. All right, so notice that we've taken our red graph and we've just pulled it up and down, okay? Like a rubber band that you're stretching. All right, now you could have done the function g of x. You could have drawn the blue graph without actually even making a table of values for it. Because if we look at this point and we're saying it is at a height of 2, and we know that we have to triple it, well then we need to go up to a height of 6. Does that make sense? So you could take all of your points and just take whatever the y coordinate is and multiply it, move it at the same time. All right. Now it says, for function f of x from the previous problem, what are the corresponding table and graph for the transformation h of x, where h of x is 1/3 of f of x? So what is a 1/3? If we multiply everything by 1/3, what's going to happen to our graph? It's going to shrink. All right? You can say vertical shrink, you can say vertical compression, doesn't matter to me. So we have to take all of these y values and make them 1/3 as tall. So in terms of our table, what that would look like, 2 gets divided by 3, right? 1/3 of it. Same thing here. 1/3 of -3 is -1. 1/3 of 1 and 1/3 of -2. Okay, we're just multiplying all of our y coordinates by 1/3. So on our graph, let's go back here and let's draw that back in here. All right, so we're going to take all of our y values and take them down to 1/3 as tall. So instead of being at 2 here, we're going to be down here at 2/3. Okay, instead of being at a 2 here, we're going to be down at 2/3. Instead of being at -3, we said we needed to be at -1. 1/3 as tall. Instead of being at 1, we're going to be down at 1/3. And instead of being at -2, we're going to be at -2/3. Okay? And then we're going to draw that in. Okay? So our graph is just more shallow. Questions about that? All right. So remember, when you're doing vertical stretches and compressions, you are just adjusting the y coordinate, right? Your x value is staying the same. All right, example 2. The graph of g of x is the graph of f of x equaling 4x, compressed by a factor of 1/2 and then reflected in the y-axis. All right, so they're not giving us a picture. They're just saying, if we were to start with this, how could we rewrite it? So we're trying to find g of x. We're starting with basically just a line, right? Y equals 4x. It's a linear equation. We want to compress it by a factor of 1/2. Okay? So we are going to take our f of x and we're going to do half of it. Okay? And then it says we're going to reflect it in the y-axis. what would happen if we're going to reflect in the y-axis? So our x's change now. So wherever we had an x, we're going to put a negative x. Okay, so we would then change this. Our next step would be like that. We're going to take half of our initial function and we're going to change our x's to be the opposite. Okay, so let's actually do that with what we have here. We are told that f of x is 4x. So we want to take half of the 4x. Yes? We want to do half of it to compress it. And then we want to change all of our x's into negative x's. What does that turn into? Half of 4 is 2. 2 times a negative x. Okay, so our new function would be negative 2x. Okay? I'm going to pause the recording here for a minute, let you guys talk about this one. It says, what transformations will change the graph of f of x into the one of g of x? So we want to take a 2x squared and turn it into a 6x squared minus 1. Talk at your tables about what was done to that. So what did you come up with? What are we doing to 2x squared? Okay, so if we took our f of x function and multiplied it by 3, that would turn it into a 6x squared. But then what else did we do to it? We had to subtract 1 from it, yes? So the transformations that we are doing to get to g of x, the 3 is going to do what? Okay, so we did a vertical stretch, and then our abbreviation is BFO, by factor of 3. We did a vertical stretch by a factor of 3. And then we did what? We did what kind of translation? Down 1. Okay. Agree with that? That would take our 2x squared and turn it into a 6x squared minus 1. Okay. Our next one says the graph of g of x is taken from the graph of f of x equaling x. So again, that basic parent function for our linear family, right? Our easiest linear graph. We're going to stretch it vertically by a factor of 2. And then we're going to translate it down 3. So what would my new equation look like? I have to take f of x, I have to multiply it by 2, and then subtract 3. I want to go down 3. Okay, so now just dump in your initial equation. F of x was just an x, so 2x minus 3 will be our new function. Okay, it'll take that line, stretch it vertically. In this case, it changed the slope, right? Slope is twice as steep, and then moved it down 3. All right, this one I've given you the equations. We are taking our parent function for our quadratic family, y equals x squared, and we want to shift it into x plus 4 quantity squared minus 2. Which way did we move? So this was strictly translations. Okay, so we translated it. I heard left 4 and then down 2. All right. I'm going to give you an equation. I want you to tell me what's been done to it. Remember yesterday we talked about the order being really important. Okay? Make sure you're listing the translations or transformations in order from left to right. All right, so all right. If I gave you g of x being negative 2 times the absolute value of x plus 5 plus 1, What have I done to the parent function? My parent function would just be absolute value of x, right? I've taken a basic absolute value graph. Now what have I done to it? Okay, I'm going to pause this, let you talk about it at your tables. All right, what kind of discussions did you have about this one? Because I know there's some issues that came up when I was walking around. You had some questions. What confused you? Nobody's going to say it now? The -2. What does that -2 do? Because we've talked about the number in front of it being a stretch or compression, but we define stretches to be numbers bigger than 1 and compressions to be things between 0 and 1. So what is a negative going to do? You actually have to think of that -2 as two different things happening. Separate the negative from the 2. What is a negative in front of your whole equation doing? It's reflecting over the x-axis. So this actually had 4 different transformations. The negative caused it to reflect over the x-axis. The 2 caused it to do a vertical stretch. By a factor of 2. All right. So that -2 in front is doing 2 things. It's flipping it over and it's making it stretched. Then what does the 5 do? The +5 is going to move it left 5, and the -1 or the +1 goes right 1. I'm sorry, yes, up 1. Thank you. Okay, yes? So when you're analyzing transformations, you want to do what we just did, working from left to right, put them in that order. You'll always land where you're supposed to land with your graph. If you try to do them in a different order, sometimes it'll work, sometimes it won't. It depends on which order you pick. This is a fail-safe way, okay? If you have it in this format and you just analyze it from left to right, you'll land where you need to go, okay? So a negative in front is going to be an x-axis reflection. Separate that negative from the number in front that is your stretch or compression. Okay? All right. I'm going to put the homework assignment up here. I do want to talk for a brief minute about some of the formative quizzes that we've been doing, but I'll give you a chance to copy that down.